In the last lecture, we have seen the problem based on the coefficient of correlation, and we have solved one problem based on coefficient of correlation. So let us try to solve some more problems based on coefficient of correlation. Okay, so we try to get an example. So this is the example given to us. Okay, now you please write down this. Okay, so we have to find the Carl Pearson coefficient of correlation. Okay, between the height and the weight of a group of people in the city from the following sample data. So this is the sample data given to us. The height is given in the inch, and then the weight is given in kg. And then we have to find the correlation of coefficient. So what is the coefficient of correlation we have? Okay. So let us try to find this. The first thing that we have to do is write solution. So suppose let R be the coefficient of correlation. Correlation between the height capital X and the weight capital Y. Okay. So what we have is we have all R is equal to, we know, summation xy square root of summation x square into square root of summation y square, or this you can write as summation. What we have here, this is xi minus x bar into yi minus y bar upon what do you have here? This is square root of, I'm writing this two square roots together, summation xi minus x bar square into summation yi minus y bar square. Okay. So what we get here? We get where what is small x? Small x is x minus x bar is in deviation of x from x bar. What is small y? Small y is capital Y minus y bar is in deviation of y from y bar. Okay. What is x bar? So we have to be careful for the notation. So x bar is summation x upon n, and what is y bar? Y bar is summation y upon n, where n is number of observations. Number of observations. Okay. So that's what we have. Now is that I'm we have here. So after having all these terms here, we have n is equal to how many observations are given in the problem. So that we need to check how many observations are there. So we have 1, 2, 3, 4, 5, and 6. So here the value of n is going to be 6. Okay. Now once we have this value, then we calculate the table. Okay. So what we have here, consider the following table. Okay. So what is the table we have to consider? See, what we want, we are given with x, we are given with y, then we want small x, which is capital X minus capital X bar. Then we'll be having small y, which is capital Y minus capital Y bar. Then we have small x into y. Then we need a small x square, and then we need a small y square. So this is the table that we have to find. Okay. Now let us see. So better I'll draw this table. I'll have so this is x, this is y. Small x is equal to capital X minus x bar. Small y is equal to capital Y minus y bar. I'm having small x into y. So then I can extend this square. Please make the table properly so that we'll have the proper calculations. Okay, so last row will be for the summation. So last three rows are more important to us. That we are going to use only the value. We don't need this summation. We need this three summations to find the R. But for that, we need to calculate all this. Okay. So what are the observations we have? So it is 48, 56, 66. Okay. So we have 48, 56, 66. Then what we have here? 18, 28, 51. So 18, 28, 51. Then we have here, this is 76, 85, 59. So 76, 85, 59. Then what we have here, 70, 80, 65. Okay. So 70, 80, 65. And this last row is for the sum of this. So you please calculate the sum of this and then tell me what you get. So somebody got the sum? What is the summation of x and y?
0, sir.
Summation of x you got 390 and 312. Okay. So we have this is 390, 312. Okay. So once we get the summation, the first thing that we have to do is calculate x bar and y bar. So we have x bar is equal to summation x upon n, and that is 390 by 6. So calculate this, and y bar is equal to summation y upon n, and this is 312 by 6. So what this is going to be?
65, sir.
65.
Yes, and 52.
65 and 52. That's great. Okay, so once we got this one, now what we have to do is we have to calculate this entries. Okay, so we have to calculate these entries and then calculate this table, and let me know what these values are. Summation x small x into y, summation a small x square, and summation small y square. So these are the entries that we have to calculate. Okay, so please calculate and let me know what you get. I hope you are getting this. Do you have any doubt up to the calculations up to 8? So I hope you are calculating. Okay, so please calculate and let me know what you get. I hope you are calculating. You got the summation xy. That's good. Yeah. What about the summation x square and y square? I know Pakshal you have already calculated, but let the others to calculate also. Okay, so you got the summation x square and y square. That's great. I hope all of you are calculating. It's good. What about the others? Are you calculating? I hope you are calculating the table. Okay. So are you done with the calculations in the table? Okay. Saurabh also got the values. So you tell me when you are done with Bhavesh also got the value. It's good. Janvi got the value. Yeah. So I hope most of you are done with the calculations in the table. So uh, let's see or let's match your entries with my calculation. Okay. So I hope you are able to get the table like this. So these are the calculations. Okay. So here we don't need these calculations. I have not calculated. Okay. But we are interested in these three entries, and so we got these three entries. I hope all of you have got the same. Okay. And now once you are ready with this table, so we are able to write. Hence, we can say we have. Okay. So what we do is we can make this equation one. Okay. So this formula to be equation one, and then once we are done with this table, okay. So we have to write from equation one, right? From equation one, we have. So what you'll be having r is equal to. Okay. So I want this entries. So r is equal to summation xy on root of summation x square, square root of summation y square, and that's what we're having. So it is 1473 on square root of 928, and here we have square root of 3010. Okay, so we have to be careful. 3010. Now calculate this and tell me what the value you got. What is the value you are getting for this? Okay, so good. What about the others? Okay, so you got the value 0.8813. Okay, and hence what I can say here. So we have R is equal to 0.8813. So this is the value. Okay, so we can have is the coefficient of correlation between the height and weight. Okay, so that's what we have. So this is how we are able to calculate the coefficient of correlation between the height and the weight. So do you have any doubt in this example? So are you able to do? Because there are only few who are giving the answers. What about the others? Please calculate and be with us. Okay, right. Okay, so if you are able to get it, then that's good. Okay, so I hope all of you are able to get the answer. Okay, Let us go for the next example. So we'll go for another example. Okay. So we'll consider the another example. So we have the test results of psychological test and the mathematical ability. Okay. So the students, 10 students were tested for the psychological test and their mathematical ability, and the results were noted. Okay, so this is the data of the 10 students. Okay, for the their mathematical ability and the psychological test. And now we have to find the correlation between these two test results. Okay, so here what we have is we have to consider what whether there is any relation between the mathematical ability and the psychological test. Okay, or the psychological ability and the mathematical ability. So that we have to test now, and then how good is this relation? Okay, so that also we have to consider. Okay, so let us try what we get for this. Okay, now we have the x parameter to be the psychological test, and then y parameter to be the mathematical ability. So what we do is we consider, so let R be the coefficient of correlation between the psychological test X and the mathematical ability. Okay, so that's what we have. Then we have R is equal to, what is R? Summation xy upon square root of summation x square into square root of summation y square, and it is going to be equation 1. Yeah, this is the equation 1. There we have to write what is x, y, r. Okay, so we write where small x is equal to capital X minus x bar is mean deviation of x from x bar. What is small y? Small y is capital Y minus y bar is mean deviation of y from y bar. And what is x bar? X bar is summation x upon n. What is y bar? Summation y upon n. And n is equal to what we have? Number of observations. Okay, so it is going to be number of observations. What is the value of n in this example? So here n is equal to 10. Okay. See, it is given in the example that we are having the following data of 10 students. Otherwise, what we can do is we can just calculate the number of observations and then we can have this. Okay. Now, once you have written about the formula, then what we have to do is we have to do the calculations. So we write consider the following. Okay. So we have the following table. So we know how to make the table now. Okay. So what we have do is we have to make the table. So please then make the table x, y, small x is equal to capital X minus x bar, small y is equal to capital Y minus y bar. Okay. Then x into y, x square and y square. And yeah, we have this. So the last row will be for the summation. So please write these values and then get what we get for this summation. Okay, so we are interested in summation. So we don't want the sum of this, but we are interested in x bar and y bar. So we'll get this table, and then we are able to calculate this. So we are always interested in these three sums. Okay, so anybody got the value of summation x? What is the value of summation x we got? Summation x is 990 and 980. That's great. Okay, so we got the summation x and summation y. Okay, so we got here this is going to be 990, 980, and hence we can write. So from the table we have, so what we get is we get x bar. X bar is summation x upon n. Okay, and we have y bar is summation y upon n. So this is equal to 990 by 10, and that is 99. So it is 980 by 10, and that's going to be 98. Okay, so once we are able to get this x bar and y bar, then we have to calculate the remaining table. Okay, so once you get this x bar and y bar, please calculate the remaining table. Okay, so I want you to calculate the remaining table now. I hope you are calculating the values. So anybody got the table completed? Any one of you got the value? Summation x, summation x, summation we got summation into x into y, summation x square and summation y square. So here you need to use the calculator efficiently so that you can have the answers quickly. We want what is the table? Okay, so first let us go with the table summation x, y you got. Good. What is the summation x into y? Okay. What about the summation small x square? Okay. What about the summation y square? Okay. So check your table. I hope it's good and correct. So check your calculations with my calculations. I hope all of you got this table. Okay. So as we know, we don't want these values. We are not interested in these values. We are interested in these values. So summation xy is equal to 92, summation x square is equal to 170, and summation y square is equal to 140. Okay, so that's what you got. Right. And now we have to calculate the coefficient of correlation. So we have here this formula, and then we can write from equation 1. Okay, so we write from equation 1, we have, so what are we have? Summation x into y on square root of summation x square root of summation y square. So this is 92 upon square root of, what is the value you got? Here we have, this is 170. So here we got, this is 170 and this is square root of 140. Okay, so tell me what is value you have got? What is the value of you got 0.565963? Good. Okay, so you have your 0.5963. Okay, and hence we got the value of R, and that is going to be 0.596. Okay. So this is how we are able to get the value. We can say is the coefficient of correlation between psychological test and mathematical ability. Okay, so what this means, what the R means actually. Okay, so as in the previous case, we obtained R is equal to 0.8813. And in this example, we have obtained R is equal to 0.5963. Okay, so what these values mean actually, or what is the physical significance of this values? So actually, when we say R is going to be 0.8813, so that means uh, at what confidence I can say that there is a relation, okay, between the height and weight. Okay, so I can say that 88.13% that this claim may stand that there is a relation between the height and the weight. Okay, what about here in this next example? So what we can say, so if I want to test the relation between the mathematical ability and the psychological test, okay, then I can say this claim that there is a relation between the mathematical ability and the psychological test stands only 59.63%. Okay, so here I have the confidence that it will be nearly 60%, but in the previous case, I have the confidence of 88%. Okay, so this is how this will give us the level of confidence, or the level or the degree of confidence that how good the claim we make. Okay, or how good the claim is that we are making. Okay, so that's how we are able to use this coefficient of correlation for finding the relation between the given two attributes or given two variables. So in the statistics, most of the times we consider attributes to be the variable. Okay. So that's what we have. Okay. So will you able to try more examples based on this coefficient of correlation as we have solved now? Yeah. Okay. So you will able to solve. Good. Okay. So this was given the data, and then using the data we process it, and then we got the relation, at what degree there is a relation between this given data. Now we have to consider an example. Suppose we have a contest, okay, and then there are several judges, okay, in the contest. Okay, then the question is, if we choose any winner, okay, is the winner chosen properly? Okay, that's the question. Okay, so is there any judge who was biased? Okay, or is there any pair of judges who were disagree on their decisions? Okay, so that can be tested by using the another tool called Spearman's rank correlation coefficient. Okay, so what we have, Spearman's rank correlation coefficient. Okay, now this is one of the example. The other example can be considered as, suppose there is a board meeting, and then as we have taken the decision in the case of previous example, that the dealer A and the dealer B. Okay, so once we consider the dealer A and dealer A is with us for 10 years and the dealer B is with us for 3 years, and then whatever the decision we have taken using the coefficient of correlation, okay, whether that decision stands or not. So we will know up to what percent we can consider that decision, but that decision has to be presented in the board meeting for the approval of the board, and hence now there will be some members who may favor the dealer A, and there will be some members who may favor the dealer B. So now we have to find out whether there was a given any favor given to any dealer, and that can be calculated by using the rank correlation coefficient. Okay, so this is how there are the stages of taking the decision and data analysis. Okay, so first we analyze the raw data, and then we make it fine, and then we consider again that what decision is a good decision. Okay, so let us have the definition of Spearman's rank correlation coefficient, and let us see how we are able to calculate it. Okay, so if you have any doubt, you can please ask. Okay, so here this is the raw data we are just talking about. We have given a raw data and then we are processing it. Now we'll have another raw data and then we'll get it. So I hope this is visible to you.
Yes, sir.
Yeah. Okay. So what you have here? See, we have the formula for Spearman's rank correlation coefficient. So please be careful that previous was the coefficient of correlation. Okay, Carl Pearson coefficient of correlation. This is the rank correlation coefficient. Okay, so the most important thing is that we have to be careful for the coefficient of correlation and a rank correlation coefficient. Okay, so this rank correlation coefficient is denoted by capital R. Okay, so previous was small r. Okay, so you can see the previous that we have calculated is the small r. So this is the coefficient of correlation. Okay, so what we have, this is coefficient of correlation, and this is rank correlation coefficient. So you can stress on the word rank. Okay, so if there is a word rank, then it is going to be capital R. If there is no word rank, then you can say it is going to be small r. Okay, so this way we can distinguish between this correlation coefficients. One is the coefficient of correlation, the other is the rank correlation coefficient. And now what we have here, this rank correlation coefficient is calculated as R is equal to 1 minus 6 times summation di square upon n cube minus n. So what is di here? So di is the difference between ranks. Okay, so suppose R1 is the ranks given by the judge 1, R2 be the ranks given by the judge 2 for the number of contestants. Okay, and then di is going to be the difference between the ranks given by the two judges. Okay, and then using these differences, we are able to find out. And what is n here? N is again same as the number of observations. Okay, so n is going to be the number of observations. Okay, so whatever may be the total number of contestants or whatever may be the total number of participants that we have to check. Okay. Now the question is, how do we give the ranks? Okay, so there are two things to give the rank. One is ascending and other is descending. So ascending and descending, why these two ranks stand? Okay, that's also the question, or how this both will be valid. Okay, see what happens. You know the many games. For example, how do we consider the first student, first rank holder in a examination or in a class? So what we do is we consider the number of marks or the total number of marks obtained by the student, and then we consider the maximum number is a better rank. Okay, so maximum marks, if the student obtains maximum marks, then we consider his rank is better. But better rank means what? The least number. Okay, so 1 is the least number in the ranks. So what we do is we assign one number to the student getting maximum marks, and then less than that we assign the next number, so 2. Okay, and then the student attending or obtaining less than the marks from this rank 2 number student will be assigned the rank 3. So this is the what we are doing is we are considering the marks in descending order. Okay, what we are considering the marks in descending order, and then we are assigning the rank. So the maximum number we are assigning the better rank. Better rank means the least number. Okay, so better rank means the least number, and the least number is 1. Okay, then we go on 2, 3, 4, and 5, so on. Okay, now sometimes it can be considered descending. We have considered descending. Sometimes it can be considered ascending. So what happens in ascending? So for example, you know the game of tennis. Okay, so what happens in tennis is the mistake of one participant credits to the other participant. Okay, so that means less number of mistakes you commit, your rank is better. Okay, and in that game we have the ascending order to assign the rank. Okay, so that's why the ascending is also valid, the descending is also valid. Okay, the most important thing is that whenever you assign the rank, whether it may be descending, whether it may be ascending, but you must consider same for both the participants or both the judges or both, whatever it may be, number of participants, number of judges, whatever it may be, but you should have one fixed rule for all the observations. Okay, so if you are considering ascending, that doesn't matter. If you are considering descending, that also doesn't matter. But only thing is that for one you should not consider ascending, and for other you should not consider descending. Okay, so either you will consider ascending or you will consider descending. Okay, and once you fixed it, and then we are through. So here I am going to fix the rule for our calculations. I will be assign the assign the ranks in the descending order. So maximum marks will be better rank. Okay, so this is the rule that we are going to fix now. Okay, so maximum marks will be the better rank. Okay, so it is easy to understand that we will have the maximum score. He will get the better rank. Better rank means the first rank, and so on. Okay, now, okay, so using this rule, we are able to find the ranks, and once you find the ranks, then you have to find the difference between these two ranks, and we have to square the difference. Okay, and then we are able to find the summation of square of difference, and then using that we are able to find a rank correlation coefficient. Okay, so that's what we have. So do you have any doubt in this coefficient, rank correlation coefficient? It's up to it, whatever we have discussed. Do you have any doubt? Okay, that's good. Okay, great. So you understood the difference between the coefficient of correlation small r and the rank correlation coefficient capital R. Okay, so moreover, we have one similar property in this small r and capital R. So what is that similar property? We have, okay, so what is the remark we have? The value of capital R is between -1 and 1. Okay, so we have, that is -1 less than or equal to capital R less than or equal to 1. Okay, so this is the important result that we have to consider. What this means? This means either your decision is 100% correct, your decision is 100% wrong. Okay, so this is going to be 100% correct. and this is going to be 100% raw. Okay, so this way we are able to use the capital R.